Hello guys, I am Varun Kulkarni and in today's video I will be speaking about RISC-V architecture. In present times where architectures like ARM and x86 are dominating the electronics market, RISC-V is an emerging architecture which is already being applied to cutting edge technologies and is expected to take over the electronics market in the future. The reason behind increasing popularity of RISC-V architecture is that it is an open source architecture. RISC-V is an open standard ISA which first came into existence in the 2010 at University of California, Berkeley. RISC-V works on the principle of RISC, which stands for Reduced Instruction Set Computer. I will now elaborate on some design specifications of RISC-V architecture. The first one being register sets. RISC-V architecture consists of 32 integer registers and 32 floating point registers. The integer registers in the RISC-V architecture are numbered from x0 to x31. The x0 is called as 0 register, x2 is called as stack pointer, x4 is called as thread pointer, and x8 is called as frame pointer. The floating point registers are used for floating point arithmetic and they are numbered from f0 up to f31. I will be making another separate video on what exactly is floating point arithmetic and how floating point operations are performed, but that will be in a separate video. Number 2 is memory access. The instructions in RISC-V architecture are little endian. The reason being, little endian instructions are easier for the CPU to process. Number 3 is packed SIMD. SIMD stands for single instruction multiple data, which is a type of parallel processing used for digital signal processing. So packed SIMD is actually used extensively by commercial CPUs in order for multimedia and digital signal processing. The basic systems which have implemented RISC-V architecture have used floating point registers in order to perform parallel SIMD. Number 4 is embedded subset. Embedded subset, also called as ESET, is a kind of an instruction set which has been developed in order to make the design and development of embedded systems to be easy. One specification of embedded subset is that instead of 32 integer registers, only 16 integer registers are used. And for floating point operations, floating point extensions are used in order to perform the floating point arithmetic. The floating point extensions, consist of converting integer to floating point value to integer value, and so on. So these are some of the design specifications which I have elaborated. I will now be speaking about the implementations of RISC-V architecture. The first one is ETSOC1, which is developed by Espresso Technologies, and it is a supercomputer on chip which has exactly 1088 RISC-V cores. Number 2, Titan M2, which is a chip developed by Google and is included in Pixel 6 and Pixel 7 series smartphones. The main feature of Titan M2 is it provides additional security. Number 3, ESP32C3, developed by Espressive Systems, and it is a single core MCU. Number 4 is Sci-Fi. Sci-Fi, in my view, is the best example of RISC-V being an open architecture. Sci-Fi is developed by the same people who created the RISC-V architecture. So basically, like, if any person wants to design chip specification, he can approach the website of Sci-Fi and the specifications can be told. I want like these and these peripherals and all these are all the design specifications, including of the core, can be told to the Sci-Fi website. And these specifications, after getting to know all the specifications, they would then implement it using Chisel. Chisel is actually a high level hardware description language. After knowing all the specifications and after implementing this, the generator will then convert this Chisel code into low level Verilog code. And after developing into low level Verilog code, like if one wants to add more specifications or subtract some specifications, that can also be done. After doing this, the chip design simulation will be done by EDA tools. After that, the semiconductor manufacturing company will design the actual chip. So that is what I have spoken on RISC-V architecture. I hope you liked this video. If you like this video, do give a thumbs up, share the video, and subscribe to my YouTube channel. I will be coming up with more informative content on electronics, embedded systems, theoretical computer science, and mathematics. Stay tuned. Thank you.